This is part 2 of operator overloading topic. C++ allows overloading of arithmetic operators such as for addition, for subtraction, for multiplication, for division, and for remaindering. All these are called binary operators because they need two operands to be applied to. The focus of this recording is on overloading one arithmetic operator, which is addition or summation. Let's learn more about this operator overloading through this code. First, let me explain this code. This is the code that I have been using in my recordings. If you have watched my previous recording, then you should be familiar with this code. Class marks contains the floating point static array to hold the marks with the capacity 32. This is not a dynamic array, this is a static array. So we have another attribute, capacity and size. Capacity will actually carry this 32 value, that is the maximum number of marks this array can hold. Size will carry the number which will be the number of marks currently being actually stored in the array. Size will always be smaller than or equal to capacity. We have a default constructor which sets size equals 0 and capacity equals to this value 32. This is a custom constructor to receive the marks array and its size, and set capacity to this value 32, and after validating it will copy the marks into the array, and we have otherwise if the data is not valid, then it will set to the default state, which is size equals 0. In this case we cannot set this to null PTR because this is a static array and you are not allowed to set a static array to null PTR. Now display function actually checks whether the size is positive and then actually displays the marks. If size is not positive, then it will display the marks, the invalid object message. In the main function I have marks array and marks object created and display function called, and the marks array has the three marks 55.55, 66.66 and 77.77, and when I run this code I would see the output like this. So it actually displays the marks in this format. In arithmetic operator overloading, you may come across the situation where you may overload the following operators: plus for addition or summation, minus for subtraction, asterisk for multiplication, slash for division, and percentage for remaindering. So the focus I will in this video I will focus on summation, and in the next video I will have subtraction and division remaindering discussed. So to focus on the this operator overloading, first we need to establish its requirement. So to establish requirement, let me go to the main code, the code in the main function. Why do I need to overload summation? Because I need to use this plus operator with this object, right? For example, let me create another marks array. Call marks2, and let me call the previous array marks1, and let me have 88.88 99.99. So I have 2 marks and I create another object mks2 2. So this will create another object. Let me call the previous object mks1. Now if I have this 2 objects, then what I can do is maybe I may want to do something like this: add 2 marks, 1 plus mks2. Since this mks, these are 2 objects of marks type, and these are user defined type. If it was floating point or integer or other types, then it is actually defined with the compiler. It comes with the compiler. You can use this expression, but since this is the type we created, so we don't have that defined with the compiler itself. So we need to define manually for this type we have created. So once, for example, if I had integer type int x equals to 5, y equals to 6, then int z equals to x plus y, I would use in this way. So similarly, if I add these 2 things, I would actually want to set it to, let's say, another object mks. Let me call this. So here you actually want to do addition of 2 marks object and return the result and copy that to this object. So now how to do that? First you need to be clear about what does this mean, this addition mean, because these are the objects which carry the these attributes, marks, capacity and size. So what does it mean to add 2 objects? So you have to be, you should define that operation. So in this case I actually assume that this operation will actually concatenate 2 marks in 2 objects. The resulting object will have the marks array, where it will have the marks, this all these marks followed by these marks in a single array. So that is the function, or that is the operation that actually I plan to define in this case for this thing. So in this case what will happen is you would think to create a you would think that this is, for example, with this object, let me just change this to 1 and mks2 dot display. So you are using this object to call this function. Similarly, you define the function and you would be using this object to call this function, and this object will go into the as a parameter to that function, and this entire function will return something that you will actually copy to this object. Therefore we define this kind of operation using this following syntax: plus operator. So the syntax for doing this is we have a keyword called operator. This is a keyword like this void or constant, so you cannot use this operator as a variable name. Then plus, because I want to overload this operator, and inside we have a parenthesis and the body of the function. So the type, since this function is defined in this mark, so the thing on the left hand side would be of the type of this object. We want to have another object of type marks on the right hand side, so you put that type here, we don't want this function to make any changes, so we are making it as a query function, and we don't want this function to make change in this parameter object we pass as a reference. So now let me put it void for a moment. Now if I want to concatenate, how would I actually create the logic for this? I would do something like this. Let's say for int I equals to 0, I less than, let's say, size, and also you need to return this, and so that data will be copied to another object. So we want to return max type object, but we want to return by value, not as a reference, because if you return by just I'll talk about that. I'll talk about this in a moment. We want to have an object where you want to store the concatenated version of the array. So let me create a temporary object of the same type and copy the current object to it. Right, you can assign the current object to this temporary object, because all we have is a static array. If it was dynamic, then you will have the copying functionality properly defined. So now okay, so then we actually iterate in this loop for the size of this array, source array, so that we can concatenate on this at the end, is equal to mks dot size I plus plus. Then we have tmp dot max something equals to it's going to be mks dot max I. So here we cannot use I because we cannot start copying from the 0. We want to start copying from the last element of the current object. So let me create a variable int temporary size equals to, then we start actually copying from this t size plus I. Right, so yeah, I think this should be okay. And tmp dot size plus plus. So you increment each time it is copied, you increment the size of this temporary, and then finally you want to return. So this is the logic. And also sometimes if these arrays, for example, we have a size 32. So if these two arrays actually summation of the length of these two arrays is more than 32, then you don't want to keep copying, so you just want to limit the number of elements to maximum 32. So for that purpose, you also want to put another condition here, so that I mean more than 32 elements are not copied. So I is less than cap, no, should be not I, it should be t size plus I, should be less than cap. So we don't want this index to go beyond the capacity 32. So I think this should be okay here. So with this I think we should be able to run that code in the main function. So here let me call display function with this object. I think there's a display, there's a typo here, display, and display. Let me switch to the terminal, compile this code, and I'll come back and fix if there is a problem, some errors. So we are in the terminal now. Compile, and I think yeah, there was a typo. Yeah. Let me go back. It is line number 66 and 76. Line number 66. This should be MKS. I would ignore this just because this is just a warning. So the second warning, I just ignore it. Let me compile again. I think there's another problem in 68. So MKS. So execution, it actually, I mean, the first marks had the content of 55.55, 66.66, and 77.77. Second array had 88.88, 99.99, right? So after concatenation, we have this thing. So at the end of this array, these contents have been actually appended. So that was actually the purpose of that function we created. Right, so this is overloading of this addition operator. Sometimes you may also want to I mean use this operator in a little bit different way. For example, max mks equals to mks1 plus some number, right, some value, let's say 88.88. I mean, the type of the max is floating point, so I'm putting this character here. So the purpose of meaning for this operation I want to be is append this 88.88 to the max array. Let me just comment this out for a moment. So for this you need to have a overloaded version of this function where this parameter is floating point type. So let me just copy this, paste, and make changes. So here I'm going to be having floating point data or value. What I want to do here is I don't think I need this here, size. Here I do copy, create a temporary object, and if basically let me just start from the raw. So what I would do is tmp.max, let's say t size. Let me create a t size like I did before. Int t size equals to tmp.size, and t size equals to value, and increment the size, and you return temp. So this is the thing, but you know, sometimes you also want to be careful, right? So if let's say if tmp dot size is less than cap -1, if there is one space left at least, and then you do this operation, otherwise you just ignore it, you don't do anything. So let me put it here. So we have a temporary object, and then you create a variable, copy size to it, and if size maybe we can use t size is less than capacity -1, then no, it should be less than capacity. So if it is less than capacity, then you copy this value and then increase size. So now this should be okay. This is another version of function which actually will make this statement a valid statement. So let me see the output for this. Compilation, linking, and execution. So we have this 88 which was added, has been appended to the end of this array, this marks array. Now another version of this function would be, for example, if I want to do something like this, mks equals to mks1 plus, let's say, some integer value 5, and depending on the situation context, you may have different meaning for this, but in this case I am considering this for the following meaning. So 5 will be added to all the marks in array of this object. So this is the meaning I want to define in the through the function. In this case, you will have another version of this function where you have integer type value, and in this case you create I don't have this, I need to iterate int I equals to 0, I less than tm dot size I plus plus, and then tmp dot max I plus equals to val. So this is the logic I have here. So it will actually add that particular incoming value. We don't need to worry about the increasing and increasing the size, but only thing we have to do is add this value to all the elements. So you can iterate in a loop and add one by one. So with this this operation should be legal operation or not error. Quickly switching to the terminal to see whether this is okay or not. Seems it is okay. Now you can see out of 55, 5 is added to 55, 60.5, 5 is added to 66 and 77. Okay, so the code is working as we expected, and this is all I have about this overloading this summation operator. Thank you for watching this video.